Welcome back to the Deep Dive. Today, we are focusing on mastery, but probably not in the way you're thinking.
Right.
We're not talking about a new language or the latest framework or some hot new tech trend.
Hmm.
No, we're going a lot deeper. We're looking at the intellectual, the emotional, and even the physical discipline that surrounds the simple, but as we know, notoriously exhausting act of writing code.
That's exactly right. For this deep dive, we've gone through a stack of sources that are really rooted in the wisdom of a veteran programmer. We're talking to someone who spent decades building systems
And thinking about
and
it.
thinking deeply about it, not just what made the code good, but what was the mental state required to produce it. So we're looking at this really practical, personal set of rules that govern, your behavior, your mood, your whole attitude while you're coding.
Yeah, it's like the intellectual bedrock of professional software
It
development.
is.
And the source material, it's intensely focused on the mindset you need for professional success. So the mission for you, the listener, is really critical here. We want to unpack the surprising origins of true coding confidence.
And this concept the author calls error sense.
Exactly, error sense. We want to show you why success in this field isn't just about, stacking up certifications. It's about ruthlessly managing your mental state, optimizing your physical environment, and really understanding those professional relationships.
And there are some really counterintuitive ideas in here. I mean, we're going to look at why that late night dedication, pouring sweat equity into a project at 3 in the morning, why that often results in what the source just flat out calls the worst code ever.
Yeah, and maybe the most shocking thing.
Hmm.
We're going to challenge the holy grail of productivity. That state everyone wants, the flow zone. We're
Right.
going to explain why that tunnel vision focus might actually be dangerous, really dangerous to the quality and the long-term health of your project.
So yeah, let's get into it.
Okay, so let's start with the baseline, the non-negotiable requirement.
Yeah.
Why do we even need these, rigid psychological rules?
Because coding is hard. I mean, it's intrinsically, relentlessly difficult. The source establishes it right up front as an activity that is intellectually challenging. It demands fierce concentration,
Right.
and it requires you to be constantly juggling multiple competing factors all at once.
When you look at the job from the outside, it looks like a keyboard exercise. But anyone who spent like 4 hours wrestling with a complex algorithm trying to satisfy 3 different system dependencies,
Right.
they know.
Oh, they know.
The physiological demand is just enormous.
Yeah.
You are pushing your working memory to its absolute limits. You're trying to hold this mental model of the entire system in your head.
While also focusing on the next 5 lines of code.
Exactly. And sustaining that kind of concentration,
Yeah.
it requires disciplined effort.
Which is why when you add in all the other stuff, the noise of a modern office, organizational distractions, just the normal cares of life, the chance for failure, for your focus to break, it's just incredibly high.
So this professional rule set, it's designed to protect that fragile concentration.
That's the whole game.
And that brings us right into one of the most compelling insights here,
Yeah.
the origin of true, deep confidence, which the author links directly to this thing he calls error sense.
Yeah, this is a fantastic story. It's a foundational anecdote from when he was just a kid, 18 years old, learning to program. Now, he could type, but he couldn't type blind. He had to look at the keys.
And he was working on an IBM 029 key punch machine. For anyone who doesn't know, this was a big electromechanical device. You'd type your program line by line, and it would punch holes into these physical cards.
And if you made a mistake?
That card was garbage. You start over.
So the process was, first, he'd write out his programs on these paper coding forms. Then he had to translate those forms one by one onto the punched cards.
And since he couldn't type blind, he ends up spending this one long, painful night just punching hundreds of these cards, meticulously checking each one, throwing away the bad ones.
But here's where the shift happened. Over the course of that one evening, something amazing occurred. He realized he wasn't looking at the keys anymore. He'd started typing blind, not through some conscious effort, but just because his fingers, they just knew where the keys were. The muscle memory had completely taken over.
But that's not even the main insight, is it?
No, this is the real crucial part that defines professional confidence. He realized his fingers also knew almost instantaneously when he'd made a mistake.
He developed this error sense.
Exactly. That neurological feedback loop closed so fast that he could literally eject the card without even looking at it, just knowing instinctively that the sequence of key presses was wrong.
That is the core takeaway. Error sense and genuine confidence are They're just completely linked.
Yeah.
The source says the key to mastery in any field sports, music, coding is how fast you learn from your errors.
Right. If you can sense an error almost instantly, before a compiler screams at you, before a test fails, you gain this deep confidence that you're operating correctly. It just accelerates your mastery.
So it's not about being perfect and never making mistakes.
No, that's impossible. It's about accelerating that feedback loop until the mistake is just a flicker, a tiny bit of instant feedback that just guides your hand.
So the professional foundation isn't technical infallibility, it's emotional discipline. It's the ability to operate with such clarity that you minimize the time you spend in an error state.
Now let's pivot to the juggling act that demands all this focus. Why is coding so exhausting? Well, because a professional is never just writing code. You're managing four intensely competing factors all at once.
And if you drop any one of these balls.
The code fails, it's not professional.
Okay, so factor one. This is the obvious one.
The code has to work. Yeah, it sounds simple, but it means it has to be a faithful, efficient representation of the technical solution. It has to follow architectural constraints, be internally consistent. All the technical stuff.
Got it. Factor two.
This is where it gets tricky. The code must solve the customer's true needs.
The true needs, not just what's written in the spec.
Exactly. This is often the first point of failure. It requires negotiation, listening, really understanding the problem because the requirements document. It almost never perfectly captures the real-world problem. The programmer has to be a translator.
And an advocate for what the user actually needs.
An advocate, yes.
Yeah.
Great way to put it.
Okay, so let's say a developer nails both of those. The code works perfectly, and it solves the business problem. Is that enough?
Our source says absolutely not, because you haven't addressed factor 3 yet. System's health.
Systems health.
The code has to fit well into the existing system without making it worse. This is so crucial for long-term sustainability. The new code can't increase rigidity or fragility or opacity.
Okay, let's break those down. If a developer neglects that, what's the immediate, painful consequence for the organization?
Technical debt. But specifically, it's a resistance to change. Rigidity means every time you want to change one little thing, a dozen other seemingly unrelated things break.
I think we've all lived that nightmare.
Fragility means the system breaks in new and surprising ways. And opacity means nobody, not even the original author, can figure out how the different pieces are interacting anymore. So if you add perfect code that makes future changes harder, you've created a liability. You've failed factor 3.
That makes perfect sense. Okay, so what's factor 4? You said it's described as the single most difficult challenge.
It is. The code must be readable by other programmers.
And we're not just talking about comments here.
No, it's the peak of mastery. It's not about nice comments or standard variable names. The source material is emphatic. True readability means crafting the code in a way that it reveals the programmer's intent.
Why is revealing intent the absolute peak? That sounds a little abstract.
Because it synthesizes all the other 3 factors into the code's structure itself. Think of it this way. A junior programmer writes a complex loop and adds a comment, looping through the list to find the highest paid employee.
Okay.
That's just commentary. A professional, revealing their intent, would refactor that loop into a function called find highest paid employee.
So the intent is baked right into the structure and the naming, not just bolted on as an explanation.
Exactly. The structure itself tells you the story.
So if I see code that's clear, that solves the real problem, that manages its dependencies, the structure of it should just naturally scream its purpose.
Precisely. It's the ultimate difference between making a machine work and successfully communicating a complex idea to another human who's going to inherit your work 3 years from now.
And if you're juggling all 4 of those things, correctness, business needs, system health, and intent, you are just burning through mental resources at a tremendous pace.
And that's why we need discipline. Because if you can't maintain that high level of concentration, the code you produce will fail. It will have bugs, it will have poor intent, it'll make the system more fragile, it will ultimately be waste.
Which brings us right to the first golden rule of self-preservation from these principles. Do not code distracted.
This one is absolute. It governs your whole professional attitude. If you are tired or emotional distraught or distracted, you have to stop.
Just stop.
Eliminate the distractions, settle your mind before you write another line of code. The source warns that if you don't, you are almost guaranteed to be redoing that work the next day.
That's the definition of professional waste.
Mm.
And yet we have this culture that just celebrates dedication. The person pulling the all-nighter, sending emails at 2 in the morning. We romanticize this idea of the hero coder.
And the source material just demolishes that with this horrifying, career-defining counterexample, the story of 3 a.m. code.
Tell us about this one.
So this is back in 1988 at a telecommunications startup. The team is working furiously, 60, 70 hours a week. They're chasing that dream, right? Building sweat equity, getting rich.
In there.
The author was feeling extremely dedicated, working late, thinking that this intense effort was the mark of a true pro.
So one night, or really one early morning, around 3 a.m., he sits down to write a quick timing fix for an event dispatch system.
And he felt good about it. He'd been at it for 18 hours, the code compiled, it looked right on the surface. But looking back on it later, he was blunt. He called it the worst code ever.
The worst he ever wrote.
And the consequences were just devastating and long-lasting. That quick, sloppy 3 a.m. design, it introduced a fundamentally flawed structure into a critical part of the system.
And then everyone else.
Everyone else on the team, they see this code checked in by a senior developer and they assume, oh, that must be the right way to do it. So they start modeling their own work on it.
So the flaw propagated. The bad design became the standard.
Exactly. It caused these bizarre timing errors, infinite mail loops, feedback issues that haunted that team for years. Every time they tried to fix a related bug, they had to work around that initial 3 a.m. failure.
And they never had time to go back and fix the root cause.
Never. They just kept adding another patch, another wart to cover the flaw. It became a cancer on the system.
The moral is just so stark there. Dedication is. It's meaningless, or even actively harmful without discipline.
If your dedication leads to code that requires years of maintenance, it wasn't dedication. It was self-sabotage. A true professional understands that their job is consistency and quality. They tune their health, their sleep, their lifestyle so they can consistently put in 8 good hours a day.
Not 18 hours of trash coding that creates a mountain of technical debt.
That late-night hero coding is just a costly illusion.
And this rule, it goes beyond just being physically tired, right? It applies to emotional and mental distraction. The source talks about worry code.
Yes. This is where background anxieties, a fight with your spouse, a sick kid, a customer crisis, financial problems, they're just running constantly in your internal processor.
It's a universal experience for any knowledge worker. You're just staring at the screen, your concentration is shot because, 20% of your brain is trying to solve the problem of the sick child, and the other 80% is just paralyzed.
You're cognitively split. You try to force yourself to write a line of code, pass a test, but the quality is just terrible. The source is clear. That state of stupefied insensibility is no time to code.
Any code you produce while you're battling that background, worry. It's going to be trash.
And the professional solution isn't brute force. It's not about powering through. It's cognitive partitioning.
Cognitive partitioning. What does that look like in practice? Do I just sit at my desk and worry for an hour?
Ideally, you remove yourself physically. If it's a family issue, you call home. You talk it through, maybe resolve it, maybe you just find a concrete path forward that lowers the immediate anxiety.
Or if it's a business crisis.
You spend 30 minutes writing down a concrete plan of action. You externalize the stress onto paper. The goal is to move the problem from a paralyzing background task that's always running
to a discrete, time-boxed task that you can defer.
Exactly. Professional developers need to allocate personal time, maybe before work or on a dedicated break to settle these anxieties. You stop trying to write code that's just going to be thrown away. And instead, you dedicate the time to quieting that background processor so the time you do spend coding is actually productive.
You acknowledge the internal state and you deal with it. You don't just pretend it's not there.
You treat it as a professional impediment, which it is.
Okay, speaking of productivity, let's talk about the state everyone strives for, the flow zone.
Ah, yes.
That tunnel vision state where programmers feel incredibly productive. They measure their success by how many hours they can spend submerged in it. It's seen as the absolute peak of concentration.
But our source has a critical and very counterintuitive warning about it.
Which is?
Avoid the zone.
Okay, that sounds crazy. Why would you avoid peak productivity? For many developers, that's the only time they feel like they're actually getting anything done.
Because the source argues that this hyperproductive state, it isn't really infallible. In fact, it carries a heavy cognitive cost. The flow zone is described as a kind of mild meditative state where your rational faculties are actually diminished in favor of speed.
Diminished rational faculty. This is a strong phrase. What does that look like in practice?
Well, when you're in the zone, you're intensely focused on the immediate task, passing the current test, fixing the local bug, completing that one loop.
And you're writing code very, very quickly.
Super fast. If you're doing TDD, you might be flying through that red-green refactor loop, and you feel this tremendous sense of accomplishment.
But the problem is,
that deep focus makes you lose the big picture. You might be solving the immediate problem beautifully, but the architectural implications, the dependency management factor 3, or the long-term intent factor 4 all of that is being neglected because your rational, holistic faculties are dimmed.
so you make design decisions that feel right in the moment.
But that you have to completely reverse the next day when you step back and look at the whole system. The code you write in the zone comes out faster, sure, but it carries a much higher risk of structural flaws. You've traded deep, critical thinking for speed.
So what does the author do when he feels himself slipping into the zone?
He forces himself to stop. He gets up, walks away for a few minutes, or even better, he finds a pair partner.
Because pairing keeps you out of the zone.
It's one of the best ways because pairing demands constant verbal communication. You have to talk about the structure, the intent, the trade-offs. It blocks that solitary, diminished mental state by forcing you to constantly engage your higher level faculties. It makes sure you're still juggling all 4 factors.
The environment we're in is obviously so tied to managing focus. And sometimes the things we think are helping us concentrate are actually just eating up the mental resources we need.
Like music.
Exactly. Let's talk about music.
So the source material has this fascinating personal story about music and coding. This goes back to the author's setup in the late 70s. He had a private office, a PDP 1160 terminal.
And a serious stereo system with vinyl records.
A serious stereo system. We're talking Led Zeppelin, Pink Floyd. And he would just crank that stereo, thinking that the intense sound was helping him concentrate.
He thought it was like a protective barrier, a way to get into deep focus.
Yes. But then he had this realization. He was reviewing a module he wrote while listening to the intense opening of Pink Floyd's The Wall.
And what did he find?
He looked at his code, at the comments and the structure, and he found all this unnecessary complexity, and his comments were just filled with irrelevant details.
Like what?
Snippets of lyrics, random notes about dive bombers, references to crying babies from the album. The music wasn't just background noise, it was actively competing for his attention.
Wow. So the intense music wasn't helping him write well-designed code. It was consuming vital mental resources, the cognitive bandwidth that should have been dedicated to solving the actual problem.
Exactly. And while he acknowledges that a lot of people use background music, ambient tracks, white noise, to get into the flow zone.
He's suspicious of it.
He's deeply suspicious of intense music for creating high-quality code. He suggests it might just be helping people enter that diminished state of rationality. It's a resource drain disguised as a concentration aid.
Okay, so moving from internal focus to external factors, interruptions. They're inevitable. And we all know that common rude response, the programmer who just snaps or glares when someone asks a simple question.
And that often happens because they're being brutally dragged out of that unstable flow zone state.
Right. But that response is professionally damaging. It hurts relationships.
A professional attitude means you have to be polite, willing to be helpful. Because next time, you might be the one who desperately needs to interrupt someone else. So the key isn't ignoring your colleagues, it's context management.
How does a professional hold on to that complex context of their work when an interruption ends? The source gives 2 big solutions.
The first is pair programming. This is incredibly effective. If you're working with a partner, they're like an external memory bank.
So if you take a call or answer a question,
when you come back, your partner can quickly and efficiently help you reconstruct the exact mental state you were in. You can pick up right where you left off. The context isn't lost because 2 minds were holding it.
And the second solution is a mechanical one.
Test-driven development, TDD. It's a huge help. It acts like an anchor.
Because of the red-green refactor cycle.
Exactly. You write a failing test. That's the red state. If you get interrupted, that failing test is a physical, objective marker of where you are and where you're going.
So you can come back, look at the failing test, and you know immediately what you need to do next to get to green.
It's a physical artifact that holds the context for you. It provides a psychological stability that someone just floating in the zone completely lacks.
Okay, now let's talk about the complete opposite of flow, writer's block. When the code just will not come.
The worst feeling. The common response is just avoidance. You start reading emails, scheduling meetings.
Anything to avoid the blank screen.
And the causes are the same things that diminish focus. Lack of sleep, worry, fear of failure, depression.
But the solution the source provides is, it's surprisingly simple, but really effective.
Find a pair partner.
We talked about pairing to prevent the zone, but how does it break writer's block?
The source just notes how uncannily effective this is. The moment you sit down next to someone else, there's an immediate physiological shift.
You're not alone with the problem anymore.
Right. When you're alone, you're just dealing with this internal mental blockade. But when you bring in another person, you are immediately forced to articulate the problem out loud.
And just saying it out loud can break the loop.
Precisely. That externalization, plus the social need to communicate, it creates a physiological change that just breaks the block. It gets the momentum back, even if it only lasts for an hour or two. It's a recovery method.
And what about prevention? To stop writer's block from happening in the first place.
Continuous creative input. Your creative output is heavily dependent on the quality and volume of your creative input.
And the author details his preferred inputs, which are pretty varied.
Oh, yeah. He's reading about software architecture, of course, but also politics, biology, physics, math, astronomy, and high-quality science fiction and mystery novels.
Why such a varied diet? And why the emphasis on non-technical stuff like sci-fi?
Because the critical element here is the contrast between active and passive input. Just passively watching TV doesn't really stimulate creation.
Right.
The most effective creative input is defined as being actively stimulated by challenging and creative ideas. Reading complex nonfiction forces you to grapple with abstract concepts. Reading challenging fiction forces your brain to build and maintain these complex mental models of unfamiliar worlds or intricate plots.
So that active engagement generates this pressure to create something new yourself.
Yes. It's a kind of escapism, but it's an active escapism that challenges the mind and keeps the creative gears turning. So when you sit down to solve a tough coding problem, you have this reservoir of cognitive flexibility to draw from.
Okay, let's shift into the professional implications of all this discipline, starting with a harsh financial reality. Debugging time is expense.
This is a huge philosophical shift for a professional. A lot of programmers just see debugging as, something that has to be done. It's an unavoidable tax.
But to the business, it's pure waste, and it is expensive.
So the professional's goal has to be to radically reduce that debugging time. The source is very specific here. By adopting disciplines like test-driven development, you can get a factor of 10 reduction in debugging time.
A factor of 10.
And this is a hallmark of professionalism. I mean, think of any other high-stakes profession. A surgeon is judged on closing the patient correctly the first time. A lawyer is judged on their preparation. Likewise, a software developer who creates tons of bugs that require costly debugging is acting unprofessionally. They're creating expense for their client or their company.
And to really drive this point home, the source gives us this absolute nightmare scenario from 1972.
Yeah, this anecdote is incredible. It shows what happens when complexity meets one tiny flaw. So the problem was severe. Terminals used for Teamsters accounting would just freeze randomly once or twice a day.
A critical system. Business operations just grind to a halt.
And there are no logs, no counters, no obvious reason why. The users, they're 30 miles away and they are furious.
And in 1972, the debugging tools were, let's just say, primitive.
Oh, absolutely. The diagnostic process was immense. It took weeks of just interviewing users, trying to gather anecdotal data. The team could only access the computer's internals using these tiny toggle switches on the front panel.
And they couldn't even stop the computer for more than 5 minutes at a time.
So they had to invent their own debugging solution from scratch. They wrote this custom real-time inspector program in assembler.
The lowest level language.
And they had to operate it in the evenings using an ASR33 teletype console, which was this slow, clunky typewriter that printed on a roll of paper.
So what was the immediate fix they came up with just to keep the business running?
It was a total hack. They figured out they could unfreeze the terminals by having the users hit a specific user interrupt switch. It just magically reset some default values.
So they literally taught the Teamsters to hit this switch whenever they called in.
Yep. And they ran a background repair utility every single second just to keep the system semi-stable. But the true bug was still hiding in thousands of lines of unfamiliar assembler code written by a guy who had already left.
Of course.
It took intensive, prolonged study to find the root cause. It was a race condition in the circular buffer queues. The system used 3 variables to manage these data queues, and they were being manipulated by different interrupt handlers running at the same time.
So any code touching those 3 variables needed to be protected from being interrupted.
It needed to have interrupts disabled temporarily. And the programmer spent days poring over this inches-thick listing of the code. He finally found it. One tiny section in the middle of everything where one of those 3 variables was being updated while the interrupts were still enabled.
And what was the window of vulnerability there? How small was it?
2 microseconds.
Ooh!
The window where the system could be corrupted was 2 microseconds long, but because the system was always running, that window opened just frequently enough to cause a complete system freeze once or twice a day. Finding that 2 microsecond flaw cost weeks of programmer time, custom tool building, and massive business disruption.
That is the true cost of poor code and lack of discipline.
It is.
That story is it's such a sobering illustration of why coding is a marathon, not a sprint.
You have to pace yourself, conserve your resources, your energy, your creativity for the long race.
And pacing is also crucial when you're dealing with deadlines and, the inevitable lateness. The trick isn't to magically speed up.
It's early detection and total transparency.
The professional method here is to always provide 3 daily, fact-based estimates to your team. The best case, the nominal or most likely case, and the worst case.
And you update those 3 numbers every single day. And the source makes this incredibly powerful, almost moral declaration about estimates.
Which is?
Do not incorporate hope into your estimates. Hope is a project killer. It destroys schedules, it ruins reputations, and it prevents rational decision-making.
So if your fact-based estimates consistently show you're not going to hit the deadline, you have to communicate that reality immediately.
You're not reporting what you wish would happen, you're reporting what the data shows will happen.
And this transparency is so essential when managers start applying pressure, right? Insisting you do what it takes.
The professional response is to hold firm to your estimates, to make sure those 3 projections are clear. Rushing, the source argues, actually prevents developers from solving problems.
Because when you buckle under pressure and take shortcuts, you're just giving stakeholders false hope.
Which prevents them from making the necessary tough decisions, like cutting scope, or deferring a feature, or delaying the launch. You're depriving them of reality.
What about overtime? That's often seen as the solution.
Overtime is very risky. The source is clear. Working 20% more hours almost never yields 20% more work. You get diminishing returns, fatigue, lower quality, and extended overtime more than 2 or 3 weeks. It'll almost certainly fail and just lead to burnout.
So professionals should only agree to it under very strict conditions.
3 conditions. 1, you personally agree to it. 2, it is strictly short-term, a few days, a couple weeks max. And 3,
this one is the big one.
Your boss has a concrete, articulated fallback plan in case the overtime effort fails.
That's a litmus test for professional leadership.
It is. If your boss can't tell you what scope they'll cut or what delay they'll accept if the overtime fails, you should not agree to it, because it means they're just relying on hope, and we already know what hope is.
A project killer. And finally, professionalism requires rigorously defining done to prevent what the source calls false delivery.
False delivery. This is identified as one of the worst unprofessional behaviors, saying work is done when it isn't.
And this can be as simple as just rationalizing that, well, it compiled or I checked it in.
Right. And that creates this dangerous illusion of status where managers think everything is on track. The source has this vivid image for it.
Everyone is having a picnic on the railroad tracks,
while the freight train of unfinished, untested work is bearing down on them.
So the only way to avoid this is to establish an independent, verifiable definition of done.
One that shifts responsibility away from the developer's personal judgment. So this means business analysts and testers have to create automated acceptance tests first.
Using tools like Fitness, Selenium, Cucumber.
And these tests have to be written in a language that the business stakeholders can actually understand. They have to run frequently, ideally continuously. If and only if those automated acceptance tests pass, is the code truly done.
Okay, let's move to the social side of professional discipline. Collaboration. The source really emphasizes that programming is just too complex, too difficult to be done in isolation.
No matter how skilled you are, you will always benefit from another programmer's perspective, from a fresh pair of eyes.
Which leads right to the professional ethical duty of helping others.
It's considered a violation of professional ethics to just sequester yourself, hide in your cubicle, and refuse to help struggling colleagues. A professional is honored by offering help.
But that doesn't mean you have to be open to constant random interruptions all day.
No, the suggestion is a balanced approach. Maintain fair and polite office hours. Maybe 10 a.m. to noon, 1 p.m. to 3 p.m. Your door is open. You welcome questions. Outside of those hours, people know to respect your focus time.
And when you do decide to help someone, you commit fully.
You plan to spend at least an hour, maybe more, focusing completely on their problem. Your fresh perspective can be so much more effective because you aren't burdened by their mental block. You're a catalyst.
And on the flip side, there's an ethical duty when you're the one receiving help.
Yeah.
The ethics of being helped.
When someone offers assistance, you have to accept it graciously and gratefully.
You cannot, under any circumstances, protect your turf.
Or push the help away because you feel possessive of the code or you feel like you have to prove you can do it all alone. If you only need 30 minutes, accept the help for that long and then politely excuse yourself.
You're honored by offering help, and you're honored by being helped.
It builds organizational knowledge, it builds professional credibility.
And this directly challenges that common stereotype of the programmer as the arrogant, self-absorbed introvert.
Right. We often gravitate toward programming because we like wrestling with the complexities of logic more than the complexities of people.
But the reality is that collaboration is just critical for success. Since programming is so hard, we need these disciplines that force us to engage with the messy complexities of other people.
It's the only way to ensure we're meeting all four of those factors of professionalism.
And that brings us to the highest level of professional engagement, mentoring.
Which is defined as a two-way professional duty.
So senior programmers have a clear ethical responsibility to spend time training and mentoring younger programmers.
They can't just rely on training courses or books. They have to provide direct guidance, pair with them, show them how the four factors are managed in the real world.
And conversely, younger programmers have an equally important duty to actively seek out that mentoring. It's an ethical requirement for the experienced to take juniors under their wing and for juniors to pursue that mentorship to accelerate their own acquisition of error sense and professional discipline.
So if we synthesize everything we've talked about today, the central theme is it's abundantly clear. Professional coding mastery relies so much less on brute force, the long hours, the 3 a.m. grind,
The desperate sprint.
and far more on rigorous self-management, psychological discipline, and a transparent professional attitude.
It's about understanding the true long-term cost of your mistakes. I mean, that 2-microsecond vulnerability that shut down the Teamsters terminals in 1972.
Or the worst code ever, written out of sheer exhaustion in 1988.
They highlight why you have to manage your mental and physical resources as fiercely as you manage your code dependencies. Failure to manage yourself leads to technical debt that can live for years.
And all the disciplines we discussed, avoiding the flow zone, partitioning your time to deal with worry, demanding a fallback plan for overtime, defining done with automated tests, these are the bulwarks against that debt, against catastrophic failure, and against that project killer we call hope.
So we challenge you, the listener, to evaluate your own work context against these principles. Think about the status reports you contribute to. Are they grounded in 3 fact-based estimates, or are you secretly incorporating wishful thinking?
Are your systems designed to fail quickly and informatively through things like TDD? Or are you creating the potential for a 1972-style nightmare that's going to require weeks of costly detective work?
And here is a final provocative thought to leave you with. The source material suggests that while programming often feels like this inherently isolating activity, the true mark of a professional is their willingness to actively engage, to collaborate, and to fulfill that ethical duty of mentoring, turning a solitary pursuit into a shared professional craft.
So what is the state of the office hours in your own professional life? Are you honoring the duty to help? Or are you protecting your turf at the expense of your professional relationships and the knowledge of your whole organization?
Join us next week for another deep dive.